Okay, so since we have no attendees today, I'll just go through what you need to do for the lab assignment. All right. So there will be videos available for you to have a look. Although it cannot give you a hands-on experience, it'll give you a bit of idea what you will need, you would do when you attend the face-to-face lab, right? So assuming your experiment really went well, and then everything ended up with what you expected, the numbers provided within your lab assignment is in red. By the way, you will also need to complete pre-lab questions. So spend some time on the multiple choice questions. First of all, it'll help you to understand what we are working on, as well as you will be able to see similar questions on your quizzes and exams, right? Anyway, so please read everything before you start your lab assignment, because you will have to take some experimental parameters for your calculation. Otherwise, you won't be able to complete your lab assignment accurately. And if you get, so if your answer is not entirely correct, so I assume that your numbers should be plus minus 10% accuracy. But if your numbers are way out of the plus minus 10% of the correct answer range, you will get penalized, right? So please take your time to complete this one, and all the question you answer should be all on the line. Okay, so now we have one attendee. Hello, Adam. Please, I just started because it's 1:02. So the missed part, you will need to have a look at the recording, whether you like it or not. Anyway, so I will quickly go through the calculation, because I wish I can spend more than 30 minutes, but since I have a workshop to run right after this, so I really cannot spend more than 30 minutes, all right? So numbers in red are the values you're supposed to get throughout your experiment, and the underlined area you need to answer, right? So it'll be just a simple calculation, and then let's have a look at part A, gravimetric analysis. So that is the mass that you started with. So in the lab, you weighed this much mass, and then it is asking to calculate the number of moles of calcium chloride. So to calculate the number of moles of calcium chloride, you should get the molar mass or molecular weight. So to do that, you'll need to have a look at the atomic weight of each one. So we do have 1 calcium and 2 chlorine. So before we move on to this one, molar mass of calcium chloride should be, I'll just use 1 decimal place number, but when you do your calculation, please use the 3 decimal numbers or 4 decimal numbers given over here. So should be 40.1 plus, you have 2 chlorines over here, should be 2 times 35.5. So when you do the calculation, you're supposed to get 40.1 plus 2 times 35.5. So you should get about 111 grams per mole, right? So using the molar mass or molecular weight of calcium chloride, you should be able to calculate calcium mass, moles of calcium chloride. So to do it, you need to use mass of a molar mass, right? So when you do mass of a molar mass, it will give you number of moles. So 1.0 0.7757 grams over 111 grams per mole. So when you look at the unit, the grams units over here cancels out each other, right? Leaving only mole. So the operation or mathematical operation we did is correct. So let's just put some numbers on my calculator. 1.7757 divided by answer. So I have, I'll just round up, 0.016 moles. So that's the number of moles of calcium chloride. And then that is the mass you measured. So you weighed a filter paper and you weighed a filter paper plus your precipitate, which is calcium carbonate. And then so weight of calcium carbonate precipitate, it'll be just a simple calculation, right? That one minus that one. It'll give you the mass of your weight of your calcium carbonate. So 3.11, not 1 minus 2.2001. So I have 0.08 gram. So that is the mass. That one, just that one, mass of everything. Take away mass of your filter paper, right? So it will give you mass of dry precipitate. So I have 0.08. And then it is asking molecular weight of calcium carbonate, the same process, right? So you only have to look at the atomic weight. So we have one calcium, which is 40.1 plus one carbon should be 12.0 plus 3 oxygen, 3 times 16. So 40 times 1 plus 12 plus 16. So my answer is 0.001 grams per mole. Oh, hang on a second, something is not right, right? Should be the other way around. Should be 100. There should be 100. So I have 100.001, but I'll just put 100 grams per mole. So that is the molecular weight of calcium carbonate. And then you will need to calculate moles of calcium carbonate precipitated. So since we have enough information, so it is asking number of moles of calcium carbonate. And then now you know the mass of the product, which is calcium carbonate, and you know the molecular weight. So to do it, you'll just need to multiply it together, right? So 0.08 grams times 100 grams per mole. So should be the other way around. Sorry, it's the same calculation of the previous one over here, right? Mass over molar mass will give you number of moles. I thought calculating mass using the number of moles and grams per mole. Apologies, my mistake. Anyway, so it should be mass over molar mass. So when I had to look at the unit, it didn't make any sense, right? So when you write everything down, including unit, in your mathematical operation, it also tells you that your operation is not correct. Anyway, so I'm fixing the problem I had, divided by 100 grams per mole. So now that one cancels out, leaving only a certain number with moles, right? So 0.08 divided by 100, it'll be quite simple, right? So it should be 0.0008 moles. Let me just write this one down neatly. Yeah, that's fine, Adam. Or whatever you have, use your number, because I'm rounding up really heavily. I cannot spend more than 30 minutes for today's session. That's why, and then I don't really want to waste my time plus if I have a lot of, say, decimal points, I will likely make a lot of errors, right? So it should be 3 not and A. That is the number of moles I have. 1, 2, 3, 4. Yep. Hang on, is it 2? Yep, it is correct. Right. So from here to here, you also need to write a certain number down. And from, say, here to here, you don't really have to do any calculation. You will need to have a look at the stoichiometric ratio. So that is the number of moles of your product, which is 0.0008, right? So it is asking the number of moles of your starting material over here. So in this case, you will need to have a look at the stoichiometric ratio. So 1 mole of this one plus 1 mole of this guy will make 1 mole of this one and then 2 moles of this one, right? So since we have the number of moles of our product, the number of moles of each one should be should correlate well with the numbers over here, the stoichiometric ratio. Because of that, the number of moles of your potassium carbonate should be exactly the same as this one. So it should be 0.0008, as well as the number of moles of your calcium chloride. So it should be same as number of moles of your potassium carbonate. But when it comes to number of moles of potassium chloride, it should be times by 2, because when you look at the stoichiometric ratio, it's 1, 1, 1, 2 ratio. Because of that, the number of moles of potassium chloride should be 1, 6, right? So by looking at the stoichiometric ratio and the number of moles over here, this can be answered without any problem, right? So moles of potassium carbonate present in unknown solution should be same as the number of moles of your product. So the answer over here should be 0.0008. I'm not sure whether it's clear or not, right? So it should be the same. So from here, so you don't really have to do any more calculation on the number of moles. Now you need to find out the volume of potassium carbonate solution used for your precipitation. So in this case, you don't really have to do calculation. You will need to have a look at the experimental procedure. And let me just go back to the procedure. I'm not sure which number it is. Over here in number 3, it says accurately prepare 50 mils of potassium carbonate, which is K2CO4, CO3, right? So now you need to use this volume because these results are based on the accurate experimental procedure. So over here, you need to write 50. And lastly, it is asking molarity of potassium carbonate in unknown solution. So molarity is, say, molar concentration, which is given in moles per liter. So you need to find the number of moles of potassium carbonate as well as volume in liters. So by looking at these two, we have everything we need to calculate the molarity, except this one has to be in liters. So 50 ml in liters should be 0.05 liter, right? And the number of moles is already calculated or derived from the number of moles of your product. So the molarity of potassium carbonate will be moles over volume in liters, right? So when you finish calculating this one, so let's just have a look at numbers I have. I have 0.16 moles per liter. on, based on my calculator, it is 0.016. I'm not sure what what went wrong, but number should be 0.16. When you do your calculation, you should be able to see where I made a mistake, and please don't make the same mistake, right? So number over here is not entirely correct because it is based on my quick scribble. So please do not use this number. Please use your number based on your calculation. I'm just showing you the step-by-step procedure. All right. So it is asking, so question number one, which you will need to answer as well. Question number one asks for your results, indicate which reagent in the stoichiometric equation below was a limiting reagent and which was the excess reagent. So in this case, it is asking either excess or limiting reagent, right? So you just need to look at your reagent, not the product. So don't worry about this one. You need to find the number moles of this one, not based on the stoichiometric ratio, based on your experiment. So based on the calculation over here, hang on. Now I know the problem because we have too many zeros over here, right? Okay. So should it have one less zeros on each one? Yeah, I made a mistake on takeaway. Let me just fix the errors I made. There we go. All right. Anyway, so now the number is all good. Number is all good. So in the beginning, you started with 0.016 moles of calcium chloride. So the number of moles over here is 0.016. And the number of moles of your product was 0.008 or 0.08. Right? Right, now you need to look at this stoichiometric ratio. It is 1:1 ratio. So to complete this reaction over here, you need same number of moles of each one, making same number of moles of calcium carbonate plus twice the number of moles of your limiting reagent. So which one might be the limiting reagent? Which one is the limiting reagent based on the number of moles? This one has a smaller number of moles, right, in comparison with calcium chloride. You only need 0.08 moles of each to establish a complete stoichiometry. Because of that, limiting reagent will be potassium carbonate, and then calcium chloride should be excess reagent. All right, let's have a look at question number 2. Question number 2 asks, silver nitrate solution is often used as a simple test for the presence of chloride due to the low solubility of silver chloride in the interactions with chloride solution. Right? So what it is you are meant to take some filtrate during your filtration of calcium carbonate, and then you'll add aqueous silver nitrate solution, and then you'll observe whether you see something happening or not. So if you are in the lab, and I think the information is given over here, there you go. Solid white precipitate formed, right? So that is what you need to do. So you made silver chloride by adding this one in your filtrate. So in your filtrate, this is not the one you had. This is an example, but so let me just write it again. NO3 plus your filtrate, making AgCl, which is solid. These are all aqueous, by the way, aqueous. So to make silver chloride, you gotta have chlorine anion. and then you'll need to find out the source of your chlorine. When you look at the stoichiometry over here, you will see plenty of chlorine over here. So first of all, you have excess calcium chloride, so you have 2 chlorine cation exists, as well as your byproduct over here. So it should be 2, right? So unless you wash like multiple times, it should be more than 10 times, and then you collect your filtrate and then you add silver nitrate, you won't be able to see silver chloride forming. But in your experimental procedure, you meant to wash 3 times with 20 milliliters of water, which is not enough, right? You have a lot of source of chlorine. So which means you had chlorine from your excess reagent as well as your byproduct. That is why you could observe silver chloride solid, which is cloudy precipitate. Okay, so let's move on to part B. So when it comes to titration, we do need to use different. It is a different types of analysis. So in the first one, we made the solid and then we weighed it. We measure the mass of your the product to find out the concentration of your unknown. But when it comes to titration, you are creating a sort of perfect stoichiometric ratio of your starting material. And then if you did titration before, and you guys should understand how painful it is to meet the titration endpoint. Anyway, so you should be able to have a look how it works using the video link within your learning activities. Since I only have like 8 minutes, I'll just move on to the calculation straight. Right. So the molar concentration, molarity of standard acid, HCl, it is given. So it is normally written on in the stock bottle, which is given at 0.492. So this is a provided number within your lab class. And then this is the titration results from your experiment. So you did 5 titrations, and then you have 3 exactly same value, and then 2 different values. So in this case, since the values are plus minus 0.1 mil, you can add them, and then you can average as a average titer, and the other thing you can do is, since you have exactly same value for 3 titration, you can reject these 2 values. It's up to you. So I either average these 5 numbers or take the good 3 values and then average them. It is totally up to you. Anyway, so since we have exactly same endpoint at 18.9, I will use average of these 3 numbers. So average amount of titer should be 18.9 mil. Now it is asking number of moles of HCl used in average titration. So it is asking number of moles of HCl in that much HCl, right? So to calculate this one, you need to have a look at the molar concentration, which is, say, molarity of HCl is given at 0.429 moles per liter, right? And now it is asking number of moles of HCl used in average titration. So you need to find out number of moles of HCl in 18.9 mils. So to do that, you'll need to use these 2 numbers. When you multiply these together, it'll give you moles, right? But you gotta be careful that average title over here is at the moment given at mils. So you need to convert this one into liters. Right? So when you do math operation, so let's have a look. So 0.492 moles per liter times 0.0189 liters. If it's liters, you won't be able to cancel liter, right? That's why also you need to convert mils into liters. Anyway, so once you finish calculating this one, 492 times 189, I'll just round up because I have too many zeros. I have 0.008 moles, right? So now it is asking moles of potassium carbonate titrate. So again, in the titration, you don't really have to worry about the product because you're going to create perfect stoichiometry, right? So number of moles is 0.008 over here. And then by using the ratio between potassium carbonate and then HCl, you should be able to calculate number of moles of potassium carbonate, right? So it's 1:2 ratio or 2:1 ratio. So you just need to simply divide by 2, right? So when you do that, it'll be 0.004 moles of potassium carbonate. And then lastly, molarity of potassium carbonate in unknown sample. So to do that, you need to find the number of moles, which is already here, and then you need to find out the volume in your part B. So at this stage, you need to have a look at the procedure, which is right over here. So it says pipette, 25 mils of unknown potassium carbonate, right? So the volume was 25 mil. Where was it? There we go. So number of moles is 0.004, and then volume of potassium carbonate should be, I converted mils to a liter straight because that one has to be in liters. So using this number, let me quickly do the calculation. So molarity is, so to be precise, it should be 2,2, and then the previous one was based on my calculator. Don't rely on these numbers. Your number should be based on your calculation. So in the end, you will need to state the results from part A and part B. And that is all you need to do, right? So once you finish calculating this one and then put the numbers in and then save, either you can use MS Word file or PDF format, which I also have, but PDF might be a bit tricky because PDF is prepared as a form, so you only will be able to put numbers. So that doesn't matter whichever it works. Both are fine. Just complete either PDF or MS Word file, and then complete your assignment and save it as a different number, including your name and then your S number somewhere in your file name, and then you can submit yours using your learning activities. And make sure that you put your name and then number and as well as date. And that is it. And if you guys are in the lab, I tend to explain why this is smaller than part B. because when you do gravimetric analysis, you tend to lose a tiny bit of sample. That is why this is with less than always less than tachymetric analysis, and the exact number for the unknown solution is about 0.163 between 63 and then 4, right? So when you look at the actual number, titration analysis is much more accurate than gravimetric analysis, right? But you don't really have to state these ones because you don't. There's no question asking about why it is different or something like that, right? Okay, so that's it, and I'm sure you should be able to do with any trouble. And please make sure that you submit before your deadline. So you have 2 weeks until the due. If you submit after the due, you will lose like a 10% of the overall mark. Right. So is there anybody who has a question? Nobody? Good. Right. So okay. Yeah, I need to run to the workshop. So if you have any questions, please shoot me an email. All right. Thanks, guys. I will see you next time I see you either in the face-to-face lab or online. All right. Bye, guys.